Okay, let's make a start with our live online session. And as always, I provide a recording of this for anyone who's not able to join us in person. So this week's material looks at the peripheral nervous system. Last time that we met last week, we talked about the central nervous system, but now we're shifting our attention to all other parts of the nervous system that don't fall within the central nervous system, so the brain and spinal cord. I have again a plan that I'm hoping to highlight the key points of the chapter material, and that's where we're going to spend most of our time. We're under a little bit of a time crunch tonight before I move on to teach another in-person class, so I'm just going to try to go through the material. I want to be sure that I cover you everything, what you need to see, but at the same time, we're going to keep up a fast pace. This week for homework, I'm asking you to complete a chapter quiz and chapter practice anatomy activity, and both are due at the end of the week on Sunday, I believe 1 minute before midnight, and I think both of them are worth 10 points, but as always, you can check those details from your Canvas course or from the syllabus. So let's talk about peripheral nervous system. And like I mentioned, peripheral nervous system focuses on the nerves outside the central nervous system and also on the sensory organs. We're going to spend more time talking about those sensory organs later on this course. I believe it's going to be the last few weeks of our time together, studying together, that we'll have a look of that. When we think of the function of the peripheral nervous system, it really links the central nervous system to the external world. So we're collecting information from the outside world and passing it to the central nervous system through the peripheral nervous system, but we're also conducting commands, for example, for actions from the central nervous system to those effector organs in our body through the peripheral nervous system. So I think that really the way to think about this is that consider PNS as all the neural structures outside the brain and spinal cord. I'm hoping that today we would talk a little bit about receptors, nerves that do the actual supply, and we'll see how far we get beyond that. So like I'm showing in the diagram, the information comes to the central nervous system and leaves the central nervous system with the help of PNS. So let's have a look of our sensory receptors and talk a little bit about that. I also want to just jump back into the previous slide where we saw the information coming in and information leaving. Let me use the laser pointer. So we're seeing the dorsal root carrying the sensory information into the spinal cord, whereas the ventral root is going to carry the motor information out from the spinal cord. So there we're seeing our afferent and efferent nerve fibers. So familiar themes, familiar terms that you've heard before, but just making sure that we're familiar with those. So receptors collect information of the world around us, even if we have internal receptors collecting internal information. The really purpose is to detect changes in the external environment or changes in the internal environment. So what we end up seeing in the sensory organs and receptors especially is that there needs to be enough of a signal to trigger an action potential to leave that structure and pass that message to the consciousness at the central nervous system level. Notice that we only become aware and give meaning to stimulus at the level of the brain, which kind of helps us to think of this kind of a difference between sensation and perception. So sensation is us being aware of a change, perception is giving it a meaning. So we just want to make sure that we know those terms and use them. This brings us back to this homeostatic feedback mechanism loop that we've seen before. And we're really seeing that at the beginning of this session now, we'll drill down to those receptors. receptors, like I said, were detecting information from the stimulus, but there was no meaning for them yet given. That's going to happen at the control center, which often was our brain. We can classify receptors in many different ways, and one way to classify them is based on the type of stimulus, which gives us 5 different receptor types. Mechanoreceptors would deal with things like touch and other forms of that, pressure, vibration, stretch. Thermoreceptors really are detecting temperature. Photoreceptors have to do all about with vision, all about sensing the light, shapes, colors, all that sort of things. Chemoreceptors, we see many senses here that have to do with chemicals like smell, taste, even chemistry in terms of the blood content. And finally, our nociceptors, which focus on being sensitive to pain. So remember, pain is an actual or potential tissue damage. So we want to be aware of if that's happening as well. We can classify also receptors based on their location. Are they inside? Are they outside? We can also classify receptors based on their structure, either as simple or then, like I said, we'll talk about special senses towards end of our semester in one of our very last chapters. I think I already mentioned this, but again, when we're thinking of at the level of the brain of giving meanings to those things that we're detecting, that information coming in, the separation between sensation, which was being aware of the change, whereas the perception was giving it the meaning. That takes place at the level of the brain. And here I have a little diagram showing the 3 basic levels where that happens. So we have our receptors that we just talked about. We also have circuit level processing, kind of grouping things together. And then we have the finer processing, giving things meanings, where the perception takes place at typically on specific regions of the cortex. I want to mention quickly our adaptation concept of adaptation. So what we often see is that if the stimulus is consistent, we will stop noticing it. So it's really the changes that we're looking for. Some of the examples that I can think of, for example, is if you're putting a new set of clothing on in the morning, you will first kind of feel their pressure on your skin, but you get used to it very quickly, and that's important for us. Another example that I can think of is doing dishes, washing them by hand. You will feel the warm water when you put your hands in there initially, but over time you stop noticing that. So it's important that we adapt those impulses that are continuous and don't cause us any worthwhile information. We don't want to direct our resources to those. I also wanted to mention regarding the pain and especially talk about the subjective nature of the pain. Pain cannot be measured. We will talk on our BIO202, for example, about giving birth in more detail. But really, pain is something that's kind of tricky for us to treat. We can't objectively quantify pain, but we don't want our patients to be in a pain. So remember, pain warns us about ongoing or threatening tissue damage, and really anything could cause damage. We naturally do inhibit the pain signals over time, but we can also use drugs to do so. And remember, there's a huge amount of variation in pain tolerance from one individual to another, but not feeling pain would be also super dangerous for us. And we see this especially with the diabetic injuries on those patients, especially on their extremities. It is worthwhile to notice that pain does not actually always originate from the site where you feel it. And this is what we're talking about when we talk about referred pain. So pain that's from one body region, but it gets perceived as originating from different region. So there's a lot to unpack there, and I'll let you dive more into it through the lecture material, through those videos, and through your textbook. I do think that we should have a look of nerves as well. So nerves are these cord-like bundles of axons closed within the connective tissue. And we really are going to see two main groups of nerves that we're going to be talking about. We're going to be talking about cranial nerves, and we're going to be talking about spinal nerves. And I really did like this previous picture that we see here, microscopic picture of the nerve. You can see blood vessel there in the center and all of that enclosed inside a connective tissue layer. So on the next slide, I believe I was going to go through our cranial nerves. Again, I am going to be totally transparent and say that a lot of anatomy is memorization. There's good mnemonics available. The ones that I use for cranial nerves are probably not as acceptable or as suitable for teaching environments. So you come up with your own one or you look them online. But we have 12 cranial nerves. The first cranial nerve is our olfactory nerve. That's to do with the sense of smell. For vision, which is something that we rely greatly, we actually dedicate a bunch of cranial nerves. We have our optic nerve, which deals with the actual visual impulses. But then we also have 3 cranial nerves that deal with the eye muscles. Those 3 cranial nerves are going to be our cranial nerve 3, which is oculomotor, cranial nerve 4, which is our trochlear nerve, and our cranial nerve 6, our abducens cranial nerve. All of those control the eye muscles. We're also going to see that we have cranial nerve 5, which is our trigeminal nerve, involved especially with controlling the muscles of mastication. Cranial nerve 7, which is our facial nerve, controlling the facial muscles of the face. We will see our cranial nerve 8, our vestibulocochlear, to do with hearing and balance. Cranial nerve 9, our glossopharyngeal nerve. It controls things like pharynx, salivary glands, and so on. Our 10th cranial nerve is going to be our vagus nerve. That really controls, for example, things like swallowing. Our 11th cranial nerve is our accessory nerve, deals with muscles of the neck and back. And finally, 12th cranial nerve is our hypoglossal nerve controlling our tongue. I think I already kind of quickly pointed onto this, but I want to look back to it. When we're looking at the nerves, we can also classify based on the direction where the signals are traveling. We do have some mixed nerves, and we see where they're carrying messages to both directions, both to the central nervous system and away from central nervous system. But once we get close to the spinal cord, these mixed nerves separate into afferent and efferent nerves. Afferent nerves are our sensory nerves carrying impulses only towards the central nervous system, whereas efferent motor nerves carry impulses away from the central nervous system to the body peripheries. I also wanted to point out ganglia. These are where our neuron cell bodies are located within the peripheral nervous system. I wanted to talk quickly about the innervation of the skin as well. These are our dermatomes. So these are the areas of the skin innervated by each of the spinal nerve. We're going to have 31 spinal nerves, and those then can be looked which of the spinal nerves innervates which region. I think that that about brings us to the point where we're kind of at the good point to wrap it up in terms of reviewing the key highlights of this week's chapter material. I realize that this review session has been a little quicker than normally. We will definitely do another one. We'll do it on Friday typically. I'll have to see. I have some interview committees where I'm serving during Friday, but I'll make sure that we do a second session where we get into more detail about the content. And this really brings us to the end of this recording. As always, I appreciate the great work that I see coming in. I appreciate each and every one of you for being part of this class. And remember that I'm here to help, even if it is an asynchronous class. That doesn't mean that you're on your own. I'm here only a message away, or joining me remotely to sessions, or what a message board message away, or messaging me through Canvas. I really do value hearing from you, so please don't hesitate to let me know how I can be of an assistance. Until next time I get to interact with you, whether it is in a virtual setting or otherwise, thank you again, and I look forward to seeing you at that time. Thanks, bye.